Hi everyone, this is Professor Rajesh. Today I'll be continuing with the previous session of searching technique. Last class I have explained about how linear search works. Now I'll be explaining about how binary search works. To go with binary search technique works only on sorted array and it takes less iteration compared to linear search. Now coming to the binary search, the concept of binary search, the input required in binary search is you have to specify the number of elements. Here we have taken n value as 5, so I'll be entering 5 elements. Assume that we have entered 5 elements, 10, 30, 40, 50 and 60. You can see that all the elements are in sorted manner. Next is the input required is key element. We have to specify the key element which has to be searched in the array of elements. Now in the coding part, you can see we have used two variables. Low is one variable, high is one variable. Low is initialized with the value 0. High is initialized with the value n minus 1. Why do we initialize low with 0 is I want to point to the 0th index of the first array and I want to point to the last index of the array. The last index here, the last index is 4, is obtained by subtracting n minus 1 because array starts with 0. So n minus 1. Low value is 0, high value is equals to 4, n minus 1 is 5 minus 1 is 4. Now let us check the array representation. Now initially low is pointing to the index 0, high is pointing to the index 4. It is an array. Now it is not pointing to the value 10, it is pointing to the index 0. A of 0 is 10, A of 1 is 30 and A of 4 is 60. When I tell A of low, means the low value will be substituted, 0 will be substituted in this place and this value will be fetched. When I write A of high, what is the index value present at high? 4. 4 will be substituted here and this particular value will be fetched. Okay. Now starting with the binary search concept, we are using a while loop over here. These statements will be repeated again and again until this condition becomes false. Now let us check. We'll be starting with the first pass, the first iteration, where low is less than or equal to I. We'll check whether the low value is less than or equal to high value. Low value is 0 we have taken and high value is 4. Is 0 less than or equal to 4? We are just checking the condition. Yes, the condition is true. The very first thing what I'll be doing as soon as the condition is true is I'll be finding the mid. How do we find the mid? Mid is found by adding the low and high value, dividing it by 2. We are finding the center index of the array elements. 0 plus 4 divided by 2 will give me 2. Means I'm finding the middle index. Now you can find the middle index here is 2. Note one thing what you have to observe is in each pass or in each iteration, either the low value will change or the high value will change depending upon the situation. For example, if the input element is 30 we have taken. If the input element is less than the mid, then I will become mid minus 1. If the input element, key element is greater than the mid, then low will become mid plus 1. That's the logic. I'm repeating it once again. If the inputted key element will be compared with the middle element, if the input key element is less than the middle element, then I value will become mid minus 1. If the input element is greater than this element, then low will become mid plus 1. Okay, that's the concept behind here. Now coming to this, we are checking first. What we are checking, if the key element double equals to E of mid. We are checking whether the key element is same as the middle element we are comparing. If it is same, then we'll stop the process. We'll stop the process and we'll tell the key element is found in so and so process. So and so location. Now 30 double equals to E of mid. We know that we have found the mid value as 2. So substituting the mid value over here, will 30 double equals to E of 2. What is E of 2? E of 2 is 40. We are comparing 30 and 40. Is 30 double equals to 40? False. The condition is false. When the condition is false, it won't enter into the if statement. It will go to the else part. In the else part, we have to check for the condition. What condition is that? If the key element is less than the middle element, is 30 less than 40? I already told you guys, if the key element is less than this, then I will become mid minus 1. We have to find I now. We are finding the new I value. I is equals to mid minus 1. What is I value? What is the mid value? Mid value is 2. 2 minus 1 is 1. Now the I gets high gets updated over here with the value 1. So you can see in this pass, low value remains the same and I value got updated. Okay. So going with the next pass, In the next pass, we already know that low value is 0, high value is updated to 1, and this is the pictorial representation which I'm shown here. In the second pass, again I'll check for the condition. What is the low value? 0 is less than or equal to high 1. When the condition is true, I have to find the mid between this both I have to find. How do I find? 0 plus 1 divided by 2. 0 plus 1 is 1. 1 divided by 2 is 0. So why 0? Because all the variables we have declared is as integer value. So 0.5. 0.5 will be discarded. 0 will be stored in mid. Then we'll be checking. Mid is pointing to the index 0. Then we'll check whether key w equals to a of mid. See students, always we will be comparing with a of mid. The key element will be found at the mid location only. When the key element is found at the mid location, we'll stop the process. 30 double equals to a of 0. What is a of 0? A of mid, right? A mid value is 0. So a of 0, what is a of 0? A of 0 is nothing but 10. 30 double equals to 10? No, it is false. Now what we'll check? Whether the key element is greater than this or lesser than this. Yeah, what we are checking here is whether the key element is less than this. No, it is false. If it is false, what happens? Low will become, your low will be changed into mid plus 1. Your low will become mid plus 1. What is the mid value we have got? Updated mid value is 0. Low will become 0 plus 1 is 1. Now the low value got updated. The pictorial representation after this pass 2 is shown here, where low and high is pointing to the index 1. Coming to the next pass, we know the low value is updated to 1 and high value is updated to 1. Now again we'll check for the condition. Low is less than or equal to I. Yes, low is, 1 is equal to 1. The condition is true. Again we are going to find the mid. Each and every time we'll be finding the mid. Mid is equals to low plus I. 1 plus 1 divided by 2. That is nothing but 1. Now your mid is pointing to the index 1. Mid is pointing to the index 1. Now when I compare, if 30 double equals to E of mid, substituting the value of mid is 1, E of 1. What is E of 1? E of 1 is 30. So you can observe that I'm comparing the key element with A of mid. Now the A of mid element is 30. The key element is found. That is 30 double equals to 30. True. When the key element is found, what I'll do is I'll enter into this if branching statement. I'll make found is equals to 1. I'll change the value of found is equals to 1 and I will break. Break in the sense, the use of this break statement is to come out of the loop. The loop is open flower braces and the closed flower braces is the while loop. This break will come out of the loop. Come out of the loop, it will come to this particular position. When it comes to this particular location, if found double equals to 1, it is checking whether the found value is changed or not. Yes, the found value has been updated to 1. 1 double equals to 1. Yes, it is true. Then it will print the location mid plus 1. Why I'm printing the location mid plus 1? Because after the third pass, the mid value is 1. Array starts with the index 0. When I write 1 plus 1, it will be printing 2 on the monitor screen. Means where is 30 present? 30 is present in the location 2. Okay, we will printing the location, and this is the program, the overall program. A header file include stdio.h is the header file we have used, and void main. The starting of C language program starts with void main, open flower braces, close flower braces. All the statements are written inside this open and close flower braces. We have declared the variables. Very first line we'll declare the variables. We have declared the array of size 10. Key found is initialized with the value 0. We know why do we use found for. If the found value is not changed, then the key element is not found. If the found value is changed to 1, then the key element is found at a particular location. And we have used a variable called as mid, low, and I. The next line, enter the size of the array. We specify what is the size of the array or how many elements you want to enter into the array. The value will be stored on inside the variable n. Depending on the n value, we'll be inputting the array elements. Enter the elements. Now, depending on n, if n value is 5, I'll be looping 5 times. 0 is less than 5. So if the condition 0 is less than 5 in the sense, I have to loop 5 times. First time when I loop, I'll enter the value of a of 0. Second time when I loop, I'll enter the value a of 1. So third time a of 2, a of 3, a of 4. When I value becomes 5, condition becomes false, it will come out of this for loop. So we would have entered 5 element. Then enter the key element. You are storing the key element in the variable called as key. You are initializing the variable year. Low can be initialized year or year only. I should be initialized after inputting the value for n. You can't initialize I is equals to n minus 1 over here. After inputting the size of the array, you can write I is equals to n minus 1. Then we are checking for the condition. This was already explained how the binary search works. If the found value is 1, I'll print the position by printing mid plus 1. If the found value is not changed, then I'll tell the element is not found. This is about binary search. Thank you.